All right, today we're going to be talking about Chapter 8, Volume and Surface Area. I want to kind of give you an overview of the whole thing, and then as we approach each of these different prisms and cylinders and things, uh, I'll do some stuff in class too as we go along to kind of remind you, but just to give you a little overview of what we're looking at in the formulas. Um, I wrote down the formulas that the book has, and then I'll try to simplify some things as we go. Our essential question is, how do you find the volume and surface area of prisms, cylinders, pyramids, and cones? Okay, that's what we're going to do. And we'll break it down. We're going to start talking about volume, and then I'll introduce surface area. Okay, we'll start talking about a rectangular prism, and that's just a box. There's a picture over there. It might be a little too big for you guys to get in all that. Right here. Right here. Okay, rectangular prism. It's just a box. Okay. We have a length. I usually think of that as the longest side. We have a width. Okay, and then we got a height. Okay, length, width, and height. Okay, rectangular prism. Maybe you can see it here a little bit better. Okay, when we talk about volume, a little bit here. Okay, since that's what we're going to talk about first in the book, the volume. When you look at volume of prisms, really cylinders, most everything that we're going to look at, the book doesn't talk about a whole lot, but I'm going to talk about this, is big B times H. Volume is big B times H, where big B is the area of the base. Okay, what's it sitting on? Okay, for us here, it's right here, it's this bottom. Okay, and you find that area by it's a rectangle, so it's length times width. Okay, length times width. So there it is right there. I highlighted it in yellow here, I highlighted it in yellow here, LW. That's your length and your width, that bottom rectangle that it's sitting on. Okay, so if you take the length times the width times the height in this case, you're taking the area of the big base, the bottom, times its height. So if I come back here, it's kind of opposite for me. So there's my bottom that I'm sitting on, that's my rectangle, that's my length times my width. Okay? So if I take that area and I multiply it by my height right here, I'll find the volume here. Okay? So length times width times height is my volume. I'll look at an example of that in a second. The book has a good picture of it, talking about volume, about how, since you're taking like maybe it's inches times inches, length times width times feet, or times height, inches, 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 you get cubic inches. Inches times inches times inches is cubic inches. And what that means is there's that many little cubes in here that are each 1 inch square. Okay? And that's how many would fill this right here. If we were talking about meters, they'd each be 1 meter by 1 meter by 1 meter little squares inside there. Okay? The book shows that pretty good, and I'll highlight that when we talk about it in class. Okay? Another prism that comes into play here in this first section that we're going to look at is, in this case here, it's an isosceles triangular prism. Okay? It could be a right triangular prism. But when you think about volume here, the volume is 1/2 base times height times L here. Basically, it's the same thing. It's the area of the base times the height. I'll show you this stuff because that's what the book shows you. So when you're looking at that, but I'm going to try to simplify it here. Area of the base times the height. This is a little bigger enough we can get it all in there. Here's a triangular prism. Okay? There's your triangle prism because it's a box. Okay? So when you're looking at this, our base is going to be the triangular end. Okay? So that triangular end, since we're trying to find the base of a triangle, its length times, it's 1/2 base times height. I'm sorry. Watch my camera go in and out here. 1/2 base times height. Okay? Which you're familiar with. You've done that with a triangle before. You found the area of the triangle. So once you find the area of that base, what it's sitting on, that's just a matter of multiplying it by its height, or its length in this case. That's my little drawing shows it's an L. Okay? I'm driving my camera crazy here. So area of the base, so 1/2 base times the height, and then multiply it by the length of this right here. Okay? Which would be this L is this H. Again, we'll look more at that as we go. If it's a right triangular, then it's going to look like this. Okay, and you get the right angle right there. So your base and your height are the two sides here. Same as when we talked about triangles before. Okay, so either it's going to look something like this, where they give you base and height this way, or it's a right triangle and base and height are the two sides that make up the right angle. Okay, then it's a cylinder. Okay, for a cylinder, again, volume, area of the base times the height. The base here for a cylinder is a circle. So find the area of the circle, pi r squared times its height. Boom. Okay, pretty straight. This one's a little bit more straightforward. So pi r squared is the area of the circle times its height. Okay, the thing to be careful of here when you look at some of these examples is sometimes they give you the radius, sometimes they give you the diameter. Okay, you'll notice in the formula it's pi r squared h. So if they give you the diameter, cut it in half. So you work with the radius. Okay, so that's what we're looking at right there. I'll talk about surface area in a minute. Volume over here for a pyramid. Same thing with a cone. Okay, and I'll show you a picture of that in a second. The volume is still area of the base times the height, but if it comes to a point, okay, like a cone in a pyramid, then it's 1/3 area of that base times the height. Okay, so there's your 1/3. Most of the pyramids we'll look at are square pyramids. Okay, it could be a rectangular pyramid, but the square pyramid is still length times the width. Okay, that's your b squared in this case, b times b, because it's square on the bottom, and then multiply it by its height. The 1/3 takes care of the fact that this comes to a point and it doesn't keep its shape as it goes up. Okay, and you'll see here with a cone, same deal. Now the base is a circle, so it's 1/3 area of the base, which is pi r squared, times the height h. Okay, that's volume. So if we look at some examples here, and we want to find the volume of a rectangular prism like this, the volume is going to equal the area of the base, length times the width. So that's going to be 11 inches times 5 inches, and then times the height, 4 inches. So 5 times 4 is 20, times 11, that's 220. Inches times inches times inches would be inches cubed. Okay, the cube goes on the inches. Don't put it on the number. I'll take off if you put it on the number. It's not 220 to the third power. It's inches to the third power. Okay? If you have a triangular prism, back and focus here. Okay, area of the base, boom, boom, right here. So if this is a right triangle, so 2 and 7 are my, so I'm going to get 1/2, 2 yards, times 7 yards, times the length here, which is 6 yards. So my volume is going to equal 1/2 times 2, which is 1, times 7, which is 7, times 6, which is 42. Yards times yards times yards is yards cubed. Anytime we're talking about volume, you're going to get your unit, in this case yards, cubed. Everything's cubed to the third power when we're talking about volume. Okay, that's a quick overview of volume. Again, we'll spend a lot more time with each of these as we go through in class. Surface area. When you're looking at a rectangular prism, it's something like, maybe you can see better this way then. It's something like this right here. Here's a cube. Okay, so my cube. All right. If we were to take this cube and cut the edges and flatten it out, we get what we call a net. Okay, this is called a net right here. And you'll notice that here's my bottom. There's my 4 sides, and then I fold my top over. Okay, so when I unfold this for a cube, I get something like this. Okay, and in a cube, 1, 2, 3, 4, 5, 6 squares that are all the same area, length times width. Okay, in this particular example, this is 2 inches by 2 inches. So if I want to find the area of just this one square right here, 2 by 2 is 4 inches, 4 square inches. Okay, we're talking about area units or square to the second power. And then I can say, well, I have 1, 2, 3, 4, 5, 6 of them. So 2 times 2 is 4, times the 6 that I have here. 6 times 4 is 24 square inches is what I have right here when I look at it as a net. Okay? If I look right here, you'll see what they did. Okay? When it's a rectangular prism, okay, opposite sides are the same length, same area. The top and the bottom are going to be the same area. The two sides will have the same area each. And then the two sides this way will be the same. Okay, I got two rectangles here, top and bottom, and then my two sides. So W times H, that gives me the area of this side. And when I double it, I get the area of this side. LW, that's my bottom. So I find the area of the bottom. And when you double it, you get the area of the top included. And then LH, L times H gives me the front. You double it, I get the back. Okay? Again, when we get into class, I'll go over this a lot more. But basically what we did is we found the area of a side, the bottom, and the front. Add them together and double it, and you take care of the other side, the top, and the back side. Okay? Surface area of a triangular prism. You have two triangles on the ends that are the same size. Okay? So big B times H, base times height. Now it's, for a triangle, it's 1/2 base times height. So when I double it to get the other side, 2 times 1/2 just gives me BH, because 2 times 1/2 is 1. And then you have L times S right here. And since this is an isosceles triangle, that means these two sides are the same length. Then that rectangle right there is the same as this rectangle right here. That's why they doubled it. And then LB, length times width, gives you the base, the bottom. So again, I didn't draw up a net for this one, but when you think about unfolding this thing, these things, or you look at each of the sides, you're basically finding the area of every side and adding it together. Okay? Again, it's hard to look at it this way in 2D when we're talking about 3D. I think we'll do a lot more of that in class with you. Okay? For a circle, here we go. A cylinder. Imagine this is my cylinder. Okay? And that's an H on there. That's my height. Okay? And I look at my cylinder, and I look at it this way. Okay? That distance around that circle, we've talked about it before, is a circumference. That's a circumference. Okay? Circumference of a circle is 2 times pi times r. So that distance around here, right here, is 2 times pi times r. When I open it up, I get that. I don't know if you can see that. That's 2 pi r. That's my height. When I take this cylinder and I cut it this way, I open it up. This side that wraps around here is really a rectangle. And the area of that rectangle will be 2 pi r times h. That's where that comes from. 2 pi r h. That's the side here. And then the 2 pi r squared is the area of the top. And I double it because I got a bottom also. Okay? That's the, so surface area for a cylinder is right here. Again, we're going to do this a lot more in class. Square base pyramid, you find the area of your base. In this case, it's b times b squared. And then you've got 4 triangles in this case. Since it's a square pyramid, every triangle, each of these 4 triangular sides, is all the same area. So it's 1/2 base times height. And this is S, slant height, because we're talking about the height, in this case, of the triangle right here. Okay? So 1/2 B times S. And since I have 4 of them the same, 4 times 1/2 is 2. So you get 2 BS. Okay? And then you'll add them together. Again, we'll look at that more in class to get a better idea of what that's all about. Cone, similar deal. Okay. You got a circular base, pi r squared, and then the area of the cone part here is pi rs, where s is the slant height. So um, rather than go into all the specifics of it, just know it's pi 3.14 times the radius times your slant height. Okay? So that gives you the area around there, and you add the circular area, and you have the total surface area. Okay? Again, we're going to look at that a lot more in class as we go. This is just to give you an idea, kind of get you thinking about it, and then we'll make it all come together in class. Okay? So this is for Chapter 8, and we'll get busy on tomorrow. See you then.